Meetups. So I just will start from the introduction, going a bit deeper, and then we will talk about materialized views. I will show some older previous examples of my implementation with Azure functions, and then I will show what is currently, what kind of a feature now currently in preview. Yeah, and we will talk about some details. So, few words about me. My name is Olena Borzenko. I'm from Ukraine originally. Currently, I'm living in Germany, in Berlin. Right now, I'm in the Netherlands because I decided that I want to go to the office today. It was a mistake because it was way too hot. So I'm a software consultant at Experience Germany. I'm also Microsoft Azure MVP, also international public speaker. I started my public activities somewhere around 1.5 years ago. And I'm also a part of the admin team for Global Azure Conference. So it's a community event. We're organizing it every year. Maybe someone already heard of it. There is a QR code on the screen, and you can easily scan it and connect to me on Twitter, say hi, or just stay in touch. I would be glad. And if no questions, then I will just go into the topic now. So first of all, introduction to Azure CosmosDB. As I already said, I want to give a bit of an overview of what is this technology. So who is not familiar with this? It's a globally distributed multimodal document-based database. So as you can see on the screen, there is a couple of APIs that are supported by default. So it's Stable API, Cassandra, SQL, MongoDB, and Gremlin. Beside this, Azure Cosmos DB is, of course, horizontally scaled, so there's an elastic scale out. They guarantee high availability and low latency with the 5 different consistency levels. Azure Cosmos DB is the only database that provides 5 different consistency levels. I would not go too deep into this because I think for that kind of a topic, there should be a separate session because it's a really complicated to understand it, but it's just good to know that there are 5 of them. And of course, it's comprehensive SLAs. So what it means globally distributed. Today's applications, they're requiring a highly responsive and to be highly responsive and always online. And to achieve that kind of availability and low latency, it means that our applications, our instances should be really close to our users. So they should be deployed in data centers nearby. That kind of applications, they called globally distributed. And for them, they need to have a globally distributed database as well. So for why it's needed to be able to transparently replicate the data anywhere in the world and enable the applications to operate on a copy of the data that is close to the user. So as I very often hear this phrase, there is a speed of light is always matters in this case. So Azure Cosmos DB is a globally distributed database service, and it's designed to provide a low latency, elastic scalability of throughput, a well-defined semantics of data consistency, and high availability. So once again, you can add regions to the Azure Cosmos DB after you created it at any time. So once the account created and you created the database, this is not a problem. If you decided to go with one region at the beginning, you can always add more as you go. So, and your application doesn't need to be paused or redeployed. You just add the region, and it's ready to go basically on its own. So, as you can see on the screen, so when the request is incoming through Azure Traffic Manager, there is a decision taken to which region to redirect our requests. And then on the background, basically, there is also replicas of Azure Cosmos DB. They are communicating between each other because they need to maintain data on a certain consistency level. So there's also some replications happening to the nodes. And that's how basically communication is happening under the hood. What are the elements in Azure Cosmos DB account? So we have our subscription. For the subscription, we need to create a resource group. And in the resource group, we are creating Azure CosmosDB account. Inside this account, we can create a database. So database is basically like a namespace for our tables or database for our containers. So this container can contain different items, merge procedures, conflicts, triggers, user-defined functions, and also storage procedures. Each container is basically just a collection of documents. So depending on what kind of API you're using, it will be either a collection of files, or it's going to be a table, or it's going to be graph, or something else. And each collection can contain multiple items. And again, depending on the Cosmos API, it's going to be either document, row, node, edge, or something else. Maybe they'll come up with some new item types. So in our case, I'm usually, most of the time I was working with NoSQL database or how it's called, the default API. And I always had a collection and my items are always documents. So for Azure CosmosDB, they're using so-called partitioning strategy. So for partitioning, when we have the database level, there are different containers, and for each container you have to specify partition key path. So it's called partition key, but I'm always trying to highlight that it's actually passed to a property in the file. It means that your document that you will be inserting should have like, for example, ID or age or name property, and this will be used to group your data, to group your files. So as you can see, for example, if you have partition key path age or name, we will have different type of documents, and this will be called logical partition. Besides the logical partition, there is also something that is called physical partition. We should not be concerned about it too much, but it's really good to know about that kind of thing, because this is basically a representation of shards, like sharding strategy. So this is the group of our files. As you can see that every partition key should have the same value, but the ID of the document will be always different. You can also use for a partition key actual ID of the document, but it's in this case, every logical partition will have only one file, which will allow you to query your file, to query your data really, really fast. But if you will need to have some data aggregation or something like this, this will not actually work. In this case, you will need to rethink your partition strategy. So as I mentioned before, the physical partitions, those are actually actual data centers. It's a physical machines where all our data is getting stored, and the logical partition is not always stored. All logical partition of the container is not always stored on the same physical partition. So as you can see that few logical partitions for one container can be stored on a different in different physical machine, even if they belong to the same database or the same container. Why it's happening? Because the size of logical partition, I think, can be around 20 gigabyte or something like this, and one container can have around 50 gigabyte. So it can happen that I might mistake in numbers, but actually it might happen that there is not enough space in one physical machine, so they will move logical partition to another data center, to another machine. But what is important that all your documents will be stored within one group that are related to a certain business logic, to a certain use case. And even if they are laying on the different machines, if you don't have cross-partition querying, they're still going to be really fast and they're still going to have high availability. So why it's all important, like what kind of partitions are you using, what kind of partition key you're using, because Azure CosmosDB operates on something called request units. So they're not calculating how much money you're spending, actually money in cents per request, but they are calculating request units. So it's basically the measure of computation cost for your memory, CPU, and how many IOPS operations you're doing. So this is the aggregated, basically aggregated name for how much of all the resources you need for certain read or write operation. For example, you will need to spend one request unit for a point read operation, which is one document not bigger than 1 kilobyte Then if you know the partition key and you know the ID of the document, it will take only one request unit. For the write operation, it will take by default no less than 5 request units. So you will always try to, if you need to have high availability of your data, really fast querying, really fast reads, you would want to optimize your reads by making your writes a bit heavier. And if you have the opposite, like you don't care about your reads, but you need to have really fast writes, then you do the opposite operation. Azure CosmosDB also have a built-in feature that is called change feed. So basically what is happening every time when there is event, when we insert in the document, when something changed, we updated the field, we added a new document, maybe trigger was started to work and maybe brought another document to another container, all these changes are getting stored in the change feed. So it's a persistent record of changes, of all the changes to a certain container in order they occur. So basically, it's event sourcing out of the box. You can call it like this. Change feed support in Azure DB works by listening to a certain container for all the changes, and you can consume those changes afterwards. So there is 3 different ways how you can operate with this data. The first way called pool model. So when you have all your documents stored, oh, by the way, before I move to this, actually, I forgot to mention the change feed is fully managed by Azure. So it's not something we have control over. It's not something we can turn off. It's not something we are paying for. We are only paying for actual Azure Cosmos DB. And change feed is something under the hood that is fully managed for us. So it's kind of like a benefit of Azure Cosmos DB. So when if you want to get all the data from our database from the very, very beginning, and for example, move it to another data store, another database, we can use a so-called pool model. So we can connect to a change feed and pull all the information from there, all the documents. This is very heavy operation, of course, and you need to manage everything by yourself. You need to deploy it, maintain it, and of course, all the exception handling is on you. But this is quite a good approach if you need to just one time connect to a data store, get all the information, and maybe kill it, maybe move to another Cosmos DB, I don't know. So another approach is a change feed processor. So you can use library, change feed processor library, .NET SDK, for example. You can write this change feed processor that will basically will be not a pull model, but a push model. So every time when there is a change will be happening in the database, you will specify which container you want to listen, and those changes will be pushed to you. So it's going to be like a event-based approach. So every update, every insert on a certain container, if you connected to it, you will receive them in your change feed processor. Afterwards, you can do whatever you want. You can, again, for example, aggregate your data, write it to another data store, maybe write to the different container in Cosmos DB. And this approach, actually, we are coming a bit closer to materialized view. If you would aggregate your data after receiving it and write it somewhere in a different container, this will be something basically pre-stored, pre-saved query. So I will still talk about it a bit more later. I want to say the last way, basically, how to consume data from change feed. It's Azure functions. So we can see here that Azure function is basically the same, very similar to the second approach. It will be as well like push model. The changes will be pushed to us, but the only difference that we are going to use Azure functions in this case, that we don't need to deploy it, we don't need to maintain it on our own, because still in the second case, all the hassle is on us, except that we don't need to specify like explicitly from which container, from which change feed, from which partition we want to pull the data. This will be done for us, but still we have to maintain all these things. With Azure Function, it's much easier. We just write a business logic, we publish it to Azure, and Azure manages everything for us. We just need to be concentrated on actual functionality. So in this case, it simplifies a lot the implementation process, of course. It also creates a bit of independency for the developers. So if you have different use cases, every developer can just work on its own use case without basically stepping on each other's feet. So this also allows us parallel processing of the data. We can have not just different use cases, but we can use the same data on the same data set and do some heavy calculations or aggregations. But if it's way too heavy, maybe CosmosDB would not be, with the change feed approach, would not be the best way to go. If you have really heavy real-time calculations, maybe connecting to Apache Spark or something like this will be better approach. And about integration with Azure, with other Azure services, what I already said, that if we need to do something really which is not actually fitting to Azure CosmosDB by default, and it seems to be a bit more complicated, maybe it's good approach to have a look on other services and find out what might be suitable for best. So event computing notifications and stream processing and zero downtime during the data moment. As I already mentioned, with the change feed, we can easily react on every change, and we can write data to a different data storage. We can also move our data without any interruption in how our application working. If you need to process our data, as I already mentioned before, Apache Spark or Hadoop, we can use it. There was, I think, 1 year ago or something, was introduced a new feature that Apache Spark will connect to replicas of the Azure CosmosDB on the background. And every time there is a change happening, if you provide and specify the behavior, how you want to aggregate and calculate your data, it will be happening in the basically real time. So really high computation capabilities. And of course, the event computing, every time the change happened, we can send something to Event Hub or use our Azure functions. So as you can see, the Azure CosmosDB has a lot of benefits, but also a lot of functionality and integration with other services. And now it's time to talk a bit more about materialized views. So what it actually is, I'm pretty sure that everyone is familiar with this approach from some older databases, from traditional relational databases, because there is also some kind of materialized views existing. And also the creation of a snapshot is kind of something similar to materialized views, but still. So materialized view is a pre-computed data set derived from a query. And because it's stored for a later use, it's pre-computed, and it allows us faster querying. So querying materialized view is faster than executing the actual query on the original data set. This gives us significant performance, and also can be run frequently, so we can query anytime we need this information, and it will be pre-calculated and pre-saved, so we would not spend our resources on, again, recalculating the data. So as a result, we can speed up our expensive aggregations, projections, or selection operations, especially those that are needed to be executed often and very frequent on large data sets, especially. So when would it be useful? Of course, it's really nice to have pre-calculated, pre-saved data, but when do we actually need to do this? So for example, if our query result contains really small number of rows, if we would compare it to the original data set. So if we have a user information that has a lot of data, and for some use cases, we need to just have a simple dashboard, for example, if there is a support service and we need to know what is the username and what is the user phone, for example. we can create that kind of materialized view. So every time when person will be calling, we will just find the record with information needed only for support service or help desk, and we will see this information, and no need to basically query all the data from the source table. So when query result contain results that require significant processing, including analysis of semi-structured data, aggregates that takes a long time to calculate. I guess that's pretty straightforward, that if we, for example, when I used to work at the company, when we had the delivery of beverages, we needed to know what is the stock information in our warehouse. This takes a long time to calculate all this stuff, because we had an event-based approach. So we were calculating and recording all the movements in the warehouse. Every time the item was moved somewhere, we just store this information, where it was moved and what exactly what moved. But if you need to understand the stock, you need to basically do in one go, make a calculation of the whole data set you have, and only then you will know where is your item, if you have enough, and where it's actually laying. It's like financial transactions. They also basically, you need to have the pre-aggregated data or aggregated on the fly to understand what is the current state. And of course, the view-based table does not change frequently. So if you have a more or less stable data set, but you have many different use cases when you need to show or either a piece of information or maybe transformed information, it also could be a good use case for materialized views. And benefits. So in case with Azure CosmosDB, because we might have a cross-partition queries, and cross-partition queries will be very expensive. So this will help us to reduce that kind of queries, reduce amount of request units for our existing queries, and improvement in query execution in time. In this case, it's also with a new feature that is currently in preview. They are claiming that there's basically zero coding effort, which I would disagree a bit, because it still takes a lot of effort to understand how do you properly partition this stuff to basically automate all this process, because you're not going to do this manually, creating the materialized views every time for every container. But it's still much faster if you would write, for example, Azure functions. And easy fine-tuning and monitoring of materialized views containers. So again, with this preview features, they're saying that there's a lot of possibilities how to monitor the health state, the load of those materialized views, and always be up to date. Basically, is what is happening in your system. So, I need to freeze out. It's really the temperature is rising in the room, and I'm getting like overheated. I'm trying to make sure that I will manage with everything in time. Oops, sorry. I want to go a bit in the code and just show what I was talking about before with Azure functions. So this is an example. You still can see my screen, right?
Yeah.
Okay. So this is an example that I mentioned before. When I used to work in a company that was doing a beverages delivery, we needed to have some stock monitoring, some information for dashboards. So I'm showing this just to show what is the older approach for having those materialized views. So basically, let's have an example. So this would be the create movements. This is just an Azure function that will write some data to Azure CosmosDB. And every time when something was written in my container that holds information about my articles, about my items, there is a trigger, stock change trigger. There is a trigger basically that will react to those changes and will make a calculation of my stock per location basically. So it listens to my movement container and in a certain database. It doesn't really matter the business logic, but it listens to a certain container in a certain database, and whatever changes happened, there's some calculation happened, and then it's written back to Azure CosmosDB. So all those functions, every function has one responsibility. So this function will create an item. This function will calculate for me stock. basically create this materialized view. Another function will populate the changes to a client. Another function will be available to get those materialized views from the Azure CosmosDB. But as you can see, this function is basically most important because this is actual place of creation of materialized view. This is what it takes, besides all the business logic, to connect to the certain database container, to provide how do you want to like aggregate your data, what kind of materialized view you want to create, and then save it back. If we will go to if you will go to Azure to portal with a new feature, if you would go to Azure CosmosDB, so I already pre-created one account. I have here, I have a database, and I have a feature that is already enabled. So materialized view for NoSQL API. So what it takes, if this would be turned off, you just need to enable it first, and then going to materialized view builder, you again need to enable here basically the provisions. You need to click provisions, sets two clicks basically, how many instances you want to have, and some configurations. And this already will allow you to set a certain behavior for materialized view. But this is just a pre-configuration basically. So what has to be done afterwards is actual enabling of materialized view feature in CosmosDB. So the enabling will be happening with making an actual REST API call through the Azure CLI. Currently, it's available only in this format, so you cannot just do this manually through Portal, unfortunately. Otherwise, it would be much easier to show. But in any case, to actually create materialized view for a certain container, you will need to create a JSON file where you will specify the configuration of what container you want to create, what is the source of container, and what kind of partition key you will have there. So afterwards, you will need to do a call to basically through Azure CLI, you need to make a REST API call with providing this file as the body of the request, and then this should trigger actually creation of materialized view. Yeah, so here we go. This is my actual file here. This is how the command looks like. So I already just pre-created it and saved it for myself just in case. So if we go here, as you can see, should I zoom in? I think yeah. Yeah. So what is happening here? Like we're just making a put request basically when we're providing the URL. URL, of course, will have like what is the resource, what is the database account, what is the database, what is your database, and in the end, the containers you need to specify the name of your container for the materialized view. So what is going to be a name of your materialized view? Currently, there is an example in the Microsoft documentation of how to do this, but they still have some mistakes in like in how the API call to do. So I'm not sure if it wouldn't be tricky to do from the first time to make to create materialized view in the Azure CosmosDB. But this command will work. You have to provide a body with your file, and basically when you will execute it, it will tell you that now it's queued, and it will take a bit of a time to create a materialized view. But basically afterwards, if you will come back here to Data Explorer, I already have my database here. I have a user container. Let's come here. So this user container I'm using as a source collection, and I'm saying that I want to extract ID and the username from this collection. I want to put it here in a different container that is called MB, it's materialized view users by name. And I want to create a partition key there, username. So what it will allow me to do, if I have my user container and I have some items, I will be able to very quickly get any file if I know the ID of this file. But if, for example, I need to request data by my username without having a partition key, without having an ID of a document, it will just search through all the documents that are in my container. So if I will have here more documents, it will just go make a linear search, basically. The materialized view container, when it will be created, it will have a different partition key, and it will allow me to do the same with the same speed request to receive the information with the same speed as I will do the initial query having an ID. So yeah, it takes a bit of time, so it's now in queued, and there is a way to get the status of this, but it's from my experience takes quite some time to be created. So I would not be waiting for this to get finished. I will just go back to presentation. So there are still some current limitations because it's just a feature in preview. So what it does for us, basically, what does it mean? It will take from you the hassle of creating the Azure function, to publishing it, all this stuff. So you can go just to your container, you can enable this feature and basically set it on the Azure CosmosDB level, how to aggregate your data. However, there is no where clause in the materialized view definition. It's not supported yet. So the only thing you can do is just a selection of few properties. So you can, if you have a really big table, you can say, okay, create me a container that will have a different partition key and will have only like 2 or 3 properties that will be more comfortable for querying for some other use cases. So there's also, you can project source container items, JSON object property list only in materialized view definition. So I will not read all this stuff, but I'm just quickly going through this. In materialized view definition, aliases are not supported for properties of items. It is recommended that materialized views is created when the source container is still empty. So if you have already some data in your source container and you will create the materialized view, nothing will happen. There's no magic will happen that those the previous data will be also pre-aggregated and pre-saved for you. So it's so they're saying that it's a temporary issue, but I'm pretty sure it will take a bit of time to fix it. From the other important things, there's also role-based access control is currently not supported, which I also saw for some people is quite an issue. And cross-tenant customer managed key-based encryption is not supported on materialized views. There are more limitations in the documentation, but it's just some things that I wanted to mention because I already saw some discussions happening, especially around availability zones. But yeah, in any case, it's almost 35 minutes, so I will say thank you on this. And if there are any questions or any comments, I would be happy to hear.
Well done. Thank you very much for that. There's already a question posted in the chat from Edis. Just go and read before kicking off the recording here. He wrote that he looks for use cases for CosmosDB, or he asked for use cases. And what kind of project was Cosmos best NoSQL DB choice for her?
Okay. Is it just because of NoSQL, or it's what kind of project the CosmosDB in general was best choice for me?
He is not there. He left because of his
Okay,
train.
okay. See, as I know, stored procedure in CosmosDB must be written in JavaScript. Yeah, that's true. First of all, I never used stored procedure in CosmosDB. So the scenario when I decided to go with CosmosDB, it was again this company where we had the beverages delivery. So at some point we had the monolith, and we did in 1.5 year migration to the microservices, and then at some point we moved completely to cloud. And then we had a merger with a different company happening. Because of the very high load of the amount of users, amount of items, amount of warehouses, the system crashed at some point, but not our system, their system crashed because we were merging into them. And there was the decision was taken to rewrite completely warehouse system, warehouse database. Because we had event-based approach for our event-based approach, so basically every item was scanned and it was written from which location to which location. We had a set of data and we had many different use cases of how we want to aggregate this data. So where is this item? If we have enough items, can we suggest this item to another user? So, but we were working with the same set of data. Plus, we had a globally we were thinking about global distribution because our company wanted to go global. This was also another case, and we needed to have really low latency and have high availability because sometimes the amount of orders was going just nuts. So in this case, for this case, Azure CosmosDB was really great choice for us because first of all, change feed, so we knew that we can just write our events there. I created some of the Azure functions. I never used storage procedures, and actually that was one of the cases when I was still in another discovery phase, but basically thinking about approach and thinking about technologies. We had a call with Mark Brown from Microsoft. Yeah, and I explained him our use case. I explained what we're gonna do, what we want to do, how we want to, what are the use cases, and he said that was actually his words. I hope that okay. Are you recording? Yeah. Okay, that's fine. But he said basically don't ever use search procedures. So they're written in JavaScript. Don't use it. I don't use it. No one uses it. It's just there because some people needed it, but don't use it. Just go with Azure functions. You can write your logic there. You connect to a certain container. You have your bindings. Bindings will allow you to get data or write data in Cosmos DB without too much of a hassle of connecting, creating the Cosmos client, and so on. And you can have your triggers and of course HTTP triggers for other purposes. So we had the database. It's always in the cloud. We had the change feed, and we had really easy approach of how to aggregate our data for different use cases. And the use cases, every day there was a new use case because we were operating for the warehouse. There was an employment application, there was a support application, there's different, basically we had within the client many different clients that were providing us different requirements of the same, what they want to see from the same set of data. So that's why we decided to go with this approach, and it worked. It's working still. I'm pretty sure that people in Germany know this company pretty well, so I'm not going to say a name just in case if there's any complaints. But it's working well, and learning curve was a bit like from the start it was hard to understand how to work with those bindings for Azure Function and so on, but then it went pretty easy because people concentrated on business logic and it was fine. With those materialized views that are now currently in preview, it's a bit too early, I would say, to build a like whole system running enterprise in it, but something to consider for the future. I think it's a nice thing.
Definitely, working with storage procedures is something that is quite old school, and it's just a reason to have a kind of logic mechanism in the system that you're using for shaping data. So it's using a function.
Yeah, I don't really even know what it's for. Like even he said, like I don't even know who's using it for what. So yeah,
compatibility.
yeah, that's true.
Just that. That's great. Materialized views is also really well-known pattern. Independently seen from Cosmos DB, but having this in Cosmos DB is great because you have everything that is really good in one place. Makes much more sense
Azure
in working with events.
Azure Cosmos DB now like very actively using this materialized view like words, a combination of words that people will start thinking that the whole approach is not existing without Cosmos DB, I have a feeling. But yeah, it's a known pattern, it's an architectural pattern or approach or design, like we call it whatever, but it's definitely, it doesn't have to be with Cosmos DB. It's just something they're trying to adapt, and they're doing it pretty well. I think in 1 or 2 years, this materialized view feature will be really powerful.
Yeah, I think so too.
Hope so.
Do you have kind of numbers? Because materialized, the idea of materialized views is also to make things a little bit faster and also reduced to have specific scope on data. Do you have kind of numbers? In regard to your querying from raw data? Not really, right?
What do you mean numbers? You mean
yeah, compared if you would do everything by yourself as querying data that you need in your structure from CosmosDB from raw structures. Compared to you have materialized view that is kind of a pre-compilation of the data that you really need. But I think that's hard to answer.
I don't, no. I think I mean, yeah, I cannot say actual numbers because they will vary from like how big is your file. But what I was saying before about limitations, of course, of materialized views, taking into account that now they can say only select a couple of fields from the table. It will be always much faster than whatever you will write by yourself, because whatever you will write, you will always do where, select this and this, like you will do a bit more complicated. So if you will do just plain thing, I still think that they will have it faster just because it's like all there, and I mean, it should be faster. So if it's like really identical solution, maybe it will be either the same or their solution will be faster, but they have a lot of limitations. So if you need something more smart, it will be a bit more expensive, but you have no other choice for now because it's just not possible with materialized views yet.
That makes pretty much sense. That's right.
But it's never less than 5 request units, as I said.
Save money.
In the beginning, you said that materialized views are it's only good to use them for not frequently changing data. What do you mean by frequently? So if you get a table which is changing, like, let's say every 2 hours, that's too frequently, isn't it?
Like if, you know, if you have, no, it depends also on the case. Like if you have really frequent updates of the actual aggregated data as well, and depends on what kind of set of data you are changing in this set, and your source data is also changing way too fast, maybe you need to use not materialized views, but receiving a batch of changes. So you can do this with Azure function. You will, like, if there's like in seconds, I don't know, 100 of events happening, you can receive 100 of events as a batch, and then like aggregate them and then write them, like make those bulk updates. Because if you react on every change and every update will be happening, you will have quite expensive writes. But if it's actually needed, you know, that's what I meant.
Yeah. Okay. I know what you mean.
Yeah, that's quite cool. So scenarios for creating faster apps and then also structured apps makes more sense though. That's quite good.
Yeah, it's actually was that's how I understood that it's working. I had no idea about this bulk update until I actually received the bulk of events with those Azure functions when we scanned the crate of water or something like this, of couple of crates, something like this. So there was instantly like receiving like 30 events or something like this, and I noticed that I have not one document but actually collection, because it was dynamic type. There was a collection of documents, and I'm like, oh, so you can have a bulk update and you can do it in one go instead of just doing every event processing separately, which was also another improvement. But there is also a drawback, and it can be tricky. Like you also need to pay attention. Being able to do a bulk update doesn't mean that you should do this every time, because if one of the items will fail or something like this, what you will do? Roll back, or will you process again all the data? Like if one of the, like if you receive this 30 events, and for example, you need, for each of the events, you need to get some data, like for example,
okay, I understand. Yeah, okay.
So you're doing some side operation for every, you have to do the side operation for every event, and you're processing them either sequentially or in parallel, doesn't really matter. Yeah, but you have like a bunch of time. So what you do, are you gonna like start saving the result of each event separately, or you will just roll back the whole thing if one of them fails? So something like this. So it's like basically like a transaction of items or something like this.
Transaction.
I don't know. It's like, I don't know how to say it. Like the one, basically.
There are any
transactional
mechanisms
processing.
to copy materialized views in a fast and yeah, smooth way, or is it just you have to create your materialized views for specific scenarios, and then you have to create them always
What do you mean
a new
copy
way?
materialized
Just
view?
if you have created a materialized view and it has the state with precompiled data and suppose, but you need kind of a similar materialized view, but with let's say a different set of data, just slightly different. It makes much more sense to create a bunch of them, and yeah, just
Storage is
but
cheap. Like that's also what Azure Cosmos DB. I mean, it's again depends. My favorite answer was Cosmos DB. Depends.
it
Depends
depends.
because you can store in the same container different type of documents under the same partition. But you can now they have like hierarchical keys. You can have synthetic keys. You can have like more gradual granular like selection of your data, but you can also have the same partition but different type of documents. So you can store, if you have one view that have 5 fields and you need like the same more or less thing, but they're slightly different use case, but you need to like have less amount of fields. You can still store them in the same partition, but you can provide, for example, the type. For example, one use case is like for monitoring, another case for something like, I don't know, for summary information. So when you will query data with a partition key, you will receive 5 different files, but 5 different files. Then you can say select where the type of file is a summary document or CV of the person. Yeah, and then you will receive exactly this. It will still be cheap. But of course, if there's like many use cases or many potential files, then it's just better to have a different container and different partition key and not to
Yeah, I see.
overthink
It
about it.
depends always.
It depends, but yeah, this is a possibility. This is actually a pretty cool way how to store it. If you have really similar things and you need to, and it makes sense for you to have them under the same partition. Maybe even the same like one system can access 2 different type of data under the same partition, but sometimes they need this, sometimes they need different, like maybe transformed data, maybe slightly transformed.
Okay.
So you can have like 2, 3, 5 files, maybe 10 files, but then you can say like type CV or summary document or this document, like, if it's, for example, user related data. And yeah, this also would be a way to go.
Makes pretty much sense. Thanks for clarification.
Yeah. Well, I'm glad that it makes sense, not just for me, for other people as well. Yeah, actually, I like that's why I like to work with Cosmos DB. Like, it depends, yes, but if you like every business case, every scenario have a different and interesting way of how to solve it, and there is always like alternatives. Like, you can play a lot with the partitioning, you can play a lot with the synthetic keys, like now with the hierarchical keys, but you can also play a lot with how many items, how you actually structure those items. But in any case, if you don't know, replicate your data, because like what 1 gig of data, what 50 cents or something they were saying. So it's like,
it's
7
nothing.
terabyte of data, right? So it's fine. It's okay.
Yeah, especially that Cosmos DB has so many features that you can nearly just get every use case running. So that's quite awesome.
Yeah,
It's a great product, definitely.
It might be a bit overwhelming, especially now. I can imagine that if people will start looking from very like from zero in the Azure Cosmos DB, and it will be like, oh, what to use? So there is a partition keys, there is this, there is like materialized views. Oh, let's use everything. That might be tricky in this way, like. But
yeah.
It's
when I remember
quite
Cosmos DB, when they started, Microsoft started with Cosmos DB, was just a document database, and it was called document database.
Yeah, I
was a
think
great product. but
I
now
think even now,
it's
if you
overwhelming.
Yeah, I think even now, if you look at some feature previews or something that are related to Cosmos DB, it's still like Microsoft Document DB or something. So, yeah.
Yeah, I can easily understand if someone fears Cosmos DB because it's just a big thing. it's a Cosmos DB.
It's Cosmos. It's also like if and like this cases, and I quite often hear this. It's expensive, it's complicated, and so on. Like, okay, how did you implement it? That's why it's expensive, because people sometimes think that Cosmos DB, because of this, they really forgetting about partitioning. So partitioning is one of the most, I would say, most important part of this. So if you made a mistake with a consistency level or something, you will see that something is going off, but you can also always contact the team, and they will help you how to properly set up the consistency level. But if you messed up with the partitioning, and all your data is already replicated, and there's hot partitions, and there's cross querying, and there's like, whoa, mess, and then nothing is working, then you have a spike on one of the partitions. It's like,
But that often happens if you are just going from SQL to Cosmos DB. So this is more often. So
that's, I remember when we were just starting, that's also like the different session I have, how I did exactly this. I went through from SQL to Cosmos DB. I did exactly the same thing as there, and then we looked on metrics and logs, and I'm like, oh no. Then I sat down and I was learning just the partition strategies, like for maybe 2 or 3 months, and then we had the call with Mark Brown, and then he said like, now what you're doing is good. It actually makes sense.